Beebe.
Good afternoon, everybody. Thank you for joining. We're excited about this. We have a great partnership with Phoenix Contact. Justin is going to show us a little bit about their wireless offering. Wireless is becoming a industrial accepted more and more throughout the industrial market. Some customers or companies have gone one direction or another. The nice thing about Phoenix is that we can go after different platforms across the wireless network. So if you're looking new at a new application within wireless, or you have an existing that you want to expand or connect maybe two different offerings together, Phoenix has got a great story to tell. So without further ado, I'm going to hand it over to Mr. Shade and let him go.
Thanks, Gene. So welcome everybody. Again, my name is Justin Shade with Phoenix Contact. I'm the Senior Product Marketing Specialist for the wireless products here. Just had my 14th year anniversary, so time flies when you're having fun. So today we wanted to focus on wireless communication and process applications. So today what we want to focus on is a couple of things. I want to first go into the traditional communication methods, what you typically use without wireless, and then some questions you want to ask when you're thinking about a wireless application, some wireless technologies that we see as pretty popular in the industrial space. And then I want to spend most of the time going through some real application examples of where we've used wireless and process applications to give you some ideas of the different considerations, the different hurdles, and why they chose each technology. So,
and Justin, I'm sorry for interrupting. This is Nikki. Just wanted to double check the presentation because I am not seeing it right now.
Is it there now?
Okay, and if you could put it in presentation, perfect. Thank you so much.
Must have clicked the button. Yeah, so traditional wise, when you look at industrial communication over the past years, when you don't think about wireless, you think about things like parallel wiring, wiring different I/O signals just directly back to PLC chassis for I/O points, serial communication like RS-232, RS-45. Now you're seeing a lot of Ethernet-based communications with RJ45 connectors, and for longer range applications, fiber optics. But with all those types of communications, you have to have some kind of physical path to get that cable back to your control system. So again, that gives you some limitations. It can create some hurdles. So when you're talking about wired solutions, when you start thinking about a solution and designing your system, considerations or challenges that may point you to a wireless solution are cost with the physical conduit, the physical design, permitting, and even that deployment time, how long it takes could cost you more labor. The I/O capacity, if you're bringing discrete I/O points back to your control system, or even Ethernet or serial connectors, do you have that capacity? Some older systems may or may not have all the different physical connection ports for all those devices. Physical distance, can you run a wire that far? Is there some hurdles? Is there some obstruction there that you can't overcome? The infrequent measurements, if that cable's been there for a long time, is it degrading over time and giving you some false positives on some of your readings? And then the last thing that a lot of times doesn't get considered or overlooked is the cable damage. So what happens to your process and to your system when that cable gets damaged? Not just the physical money when it comes to replacing that cable, but how much money are you losing for your process being down? And that's one thing that a lot of our customers and users don't consider when it comes to a wireless solution. They look at the upfront cost and they see, hey, this wireless solution may or may not save me on the hardware up front, but what happens if that process were to go down because of a cable getting cut? How long does it take you to replace it? And how much money are you losing in your process in that time? So the most important thing when it comes to wireless technologies is there is not one technology that fits every application. It's not like a sock. A sock can fit many feet, but a wireless technology can't fit every application. There are radios for long distance. There are radios for high bandwidth. There aren't necessarily radios for long distance, high bandwidth. So you just have to make sure when you're going through it and looking at your designs, you look at some questions. And these are some high-level questions you can take a look at when you're thinking about wireless. First thing is distance. How far do you need to go? Is it across the room? Is it across a pad site? Is it across a city? Is it across the country? You could have some local need that also turns into some long-distance remote need. So understanding the full scope of your project is important, so you can make sure you pick the right type of technology. How much data are you sending, and how fast do you need it? So again, are you sending megabits of data that you need to stream that needs to be there right on time, or you're getting some errors? Or is it just some periodic I/O updates where you're just getting some little piece of data here and there? And then what is in the way? Is it a physical obstruction? Or is it a non-physical obstruction like other RF interference? You need to pay attention to what's going to be around your system physically and in the air. Obviously, it's much easier to see the physical obstructions. It's not as easy to see the non-physical obstructions. So there are tools to look at that, but it's just make sure you consider that when you're looking at a wireless system. And the most important thing with those three questions is you got to take a look at all three of them. You can't just ask yourself, how far am I going? Because you may look at one technology as long distance, but you may also need a high bandwidth. So you may pick a radio system that gets you the distance, but doesn't support the data rates you need. So it's important just to make sure you ask all three of these questions, and that'll start you down the right path of choosing a wireless technology. So when it comes to wireless technologies that Phoenix Contact sees as a trending or a popular technology, we see three different technologies as being very popular. Industrial WLAN or Wi-Fi, proprietary 900 megahertz technology, and then your LTE or 5G technologies. So when you look at wireless LAN or Wi-Fi, these work on 2.45 gigahertz frequencies. So those are higher frequencies. So they have a little more attenuation over the air, so they don't go as far, but they get you that higher data rate. They get you 300, 450 megabits per second. Some of the newer technologies will get you into the gigabit per second data rates over the air, but you're typically limited in distance. So we say with our product lines, 1,000 feet is roughly your go-to distance. It just depends on what you're connecting and what you need from a data rate standpoint. Things you may be connecting with a Wi-Fi system, perimeter security. If you have some cameras around a yard or a pad, you might get some cameras to stream video back to a server. If you have any yards that have guided vehicles that are automatic that you need to network to your system for traffic control. Plant networking. And this isn't just in a factory floor setting. This can be out in an oil field if you need to network a bunch of devices, pump jacks, TLCs, networking those devices directly back to a backhaul. And I'm going to get into an application where we did this a couple of years ago. And then also a big one we see is mobile access. So thinking about going out into a field where you have a bunch of devices that have Ethernet connections and having to walk out, plug into that cabinet, get back into your car, and physically have a physical connection. Wi-Fi can allow you to not have to open that cabinet, get out of your car, spend that extra time. You drive up, you connect, and you're able to get your information. So again, if you take a typical site layout, you have a flow computer, an RTU that is consolidating all this data. Maybe you have Wi-Fi devices that are spread out across your area. You can network those devices together. Maybe you have some security cameras that you have some vandalism going on that you want to be able to record that information. You can throw some cameras out there. And then again, you can have a mobile operator with a mobile device or a laptop that's able to walk out to that site and wirelessly connect to that flow computer or that server that has that data consolidation. The next one we'd like to talk about is wireless I/O, which is a proprietary 900 megahertz technology. So 900 megahertz, lower frequency, gets you longer distances, but because of those longer distances, the data rates drop. So you're looking at, theoretical values are 20 plus miles. Realistically, the sweet spot is 1 to 3 miles. We see a lot of 5 to 7 mile applications. We even see some 10 plus mile applications. But it is a lower frequency technology, so it allows you to go further distances. And it uses something called frequency hopping spread spectrum technology. And what that allows you to do is have a really resilient type of communication over the air. So what we see this a lot is SCADA networking. You have PLCs, instrumentation out in the field, maybe some drives, motors, switches that have some IO connections, and you just want to be able to, hey, is that on? I want to turn it on. What's the level of that tank? I have a value there that I want to read back over, 1,000 feet, a mile and a half across town. So this technology allows you to go that longer distance for those lower data rate needs. So if you take the application of our site here, traditionally you'd have some IO that's hardwired across your site. Again, trenching, pipe, conduit, bring all that IO back to your flow computer, get rid of those data cables and put some IO devices at all these sites. And now you can wirelessly communicate to that. It's simple, it's quick. You can have a nice remote shutdown, a broadcast shutdown for all those sites. Again, it's 900 megahertz, it's frequency hopping, so it's reliable. It gives you that robust communication that is up 99.9% of the time. And again, it's simple and it helps you reduce your labor costs. And the last one, SCADA, which we use our cellular communication. So again, this has been changing drastically over the past couple of years. But this is your 3G, 4G, 5G, LTE technologies. Depending on the type of modem or device you have, you can get 100 megabits per second. It's a worldwide technology. And you'll see similar things. You typically connect PLCs, RTUs, remote IO. And again, you can use this technology for SCADA applications or remote access where you want to get into those devices, firmware updates, configuration changes, maintenance. So again, if you take that application here, you have a hybrid here where you have a mixture of wireless IO in the field that comes back to your flow computer, but now that flow computer is remote and you want to access that data, maybe across the state, a different part in the country, you can create a cellular connection, it's backhaul that could be anywhere in the country, anywhere in the world, depending on what your plan is for your cellular provider. So again, this gives you that application for a hybrid approach where you have different technologies that do different functions within your wireless network. So those are the three technologies that we typically see in a lot of the process-based applications. And now I want to give you some examples of where we've used these in the past and why we used them and some of the things we had to consider when doing that. So the first one was a SCADA networking application down in South Texas. So this was a oil field that spanned probably 20 or 30 miles square. And they had cellular modems on every single device in the field. So all the pump jacks, all the total flow PLCs, everywhere out there had a cell modem. There were 1,500 plus sites, each of them having a cell modem. So you can imagine their data plan every month was pretty expensive. They also had 24/7 on-site maintenance for all their people, for all their workers, to make sure that they had everything up and running. So what they wanted was to replace those cellular modems with a private network. And again, some of these shots were 1, 2, 3 miles. But one of the main requirements that they said is that they needed a 5 megabit per second data rate to every single end device, because down the line, they wanted to be able to put security cameras at every end device for vandalism. So, and when we first started going down this road of this application, we said, well, what do you want to connect? And they said, well, we have some Ethernet-based devices and we have some serial-based devices. And all we're doing is pulling some small data registers every 15 minutes. So my head first went to our wireless IO system because we have a serial port, we can put a gateway on there for Ethernet. It was all Modbus. So I was like, we use our wireless IO, we call our radio line network, and we can do point-to-point star networks. And these 1,500 feet mile links are pretty simple. Well, then they threw in, well, we need a minimum of 5 megabits per second per end device. So that changed the whole conversation of what technology we needed to use, because our radio line 900 megahertz wouldn't get 5 megabits per second. WLAN does, but they had some shots that are 1.5 miles, 2 miles away. That wasn't going to work either. So what we had to do is come up with a topology that worked for them. And then what they ended up doing was they ended up erecting some repeater towers in the middle, which is the middle picture on the bottom there, that one had an omnidirectional antenna for the local remote sites, and one had a high gain directional antenna pointing back to the main access point. That main access point had a satellite uplink back to their main office, which was over 300 miles away. So they ended up setting up multiple repeater towers. Each repeater tower would talk to 10 or 15 different end devices, the pump jacks, the flow PLCs, and we created shorter links from the repeater tower down to the end nodes, which enabled them to have their 5 megabit per second test from end device all the way back to their main server back at 300 miles away. So this is a great example where, asking those questions, what are you connecting to your network? How far do you need to go? What other considerations do you have for your network that may not be black and white on your paper? And with this network, they are able to save, I think they said when they installed the first quarter of the radios, they were saving $5,000 a day on their cell plans. So it was able to help them replace that physical money dollar amount on their cell plans. And then it also allowed them to reduce their labor in the field from 24/7 maintenance to 5 days a week, 8 to 5, because this network was so reliable that they never went down. They had communication all the time. The next one we have here was a typical SCADA application. So this customer had a large oil field. It was over 20 miles, but they had all their different locations were kind of spread out in between. So the longest point away was about 20 miles, but they had some other sites that were intermediate to that. So they had some EPA stuff regulations come up that they had to, monitor these real time and not have the quote unquote man in a truck type application where someone had to go out there 3 times a day and pull these levels off all these devices. So again, 20 miles is a pretty long distance, and theoretically a 900 megahertz system can do that. But if there's any hills, that won't work as well. So what they ended up doing was using a radio line system where they had IO in the field. They had our radio line network, which can work in a repeater network. So all the IO can be repeated through different nodes in the network and hop through each other to get that IO data back to the control room. So what they ended up doing with this one is setting up 2 separate networks because they had so many IO points, and they strategically put the nodes in different places, so they had repeater nodes set up throughout their oil field. And this ended up coming back via Modbus, so they had all the IO from all their different devices that came back to the control room, came out as Modbus RTU, and they were able to read all that and visualize that in their SCADA system. The next one is a refinery application, similar to the last one, where they had, again, oil refinery, where they had all these tanks where they needed to monitor their high and low level alarms. And again, you can see from the picture here, it's in a refinery, it's been there for a long time. They didn't have any way of trenching cables from tank to tank. So they were having people go out every day, 3 or 4 times a day to each individual tank and read these levels. So there are about 80, 85 tanks on this. And if you look right in the middle there's a lot of scaffolding. That's where their master radio was, or that's where their control room was. So getting through that scaffolding with a cable was not happening. So again, what they used was a 900 megahertz network. They had a radio and an analog input that used 2 channels, one for a high alarm, one for a low alarm, and one for the level of the tank. And they ran that into each radio. Again, they used a repeater network here so they could hop from tank to tank if they needed to around any obstruction that wasn't good. Because this was such an important application to them, they actually set up 2 separate networks identical to each other. That way, if anything were to happen to one of them and it were to go down, they were able to switch over to the secondary network and have the exact same readings there. Because this was a refinery tank level alarming system, they had to have a backup and had to have multiple ways of getting that information. So they are able to set up 80 radio systems. And again, since then, it's been working really nice for them and helped them reduce the cost of that man in the truck going around to each individual tank to see that information. And this is a kind of a cool one. Again, this was an automotive customer, but it rings true for, you know, refineries, sites where you have lots of assets locally, where you're trying to connect Ethernet-based assets to an existing customer's network or an existing network on your property. So this customer had an existing Cisco network in their facility, and they were looking at adding a whole new line of production for a new car. And they were going to use a Cisco network as their client connection to their Cisco network. What they found was that the Cisco hardware wasn't nice to mount. It was going to cost them a lot of money to build brackets. They were expensive pieces of hardware. So we were able to go in there and show them one of our compact WLAN devices, which you can see there on the side of the trim tool there. And we were able to save them roughly, our cost of our radio is about a third of the Cisco network. We are able to integrate with the Cisco network successfully. Our housing was more industrial, more compact, where they can mount it right to the tool and not have to build any brackets. So we have a lot of experience with networking with third-party manufacturers. So if something's already there, whether it's an enterprise IT-based network or it's another industrial manufacturer that has a Wi-Fi network sitting there, we have the ability to network and coexist with those existing networks. And then lastly, we have a water wastewater treatment plant that was looking at some upgrades. They were looking at networking some scum pumps and some motors. And again, the original idea was to hardwire and trench all these pieces back to the SCADA system, because the people there were wary of the reliability of a wireless system. So, you know, through our local Phoenix and channel partners, we were able to go out there and set up a test, show the customer that we can have a reliable network with a SCADA system, and put a demo system out there where we could run it for a little while and prove out to them that the wireless system could be a reliable system for them. So it started out as a master and 3 slaves, just networking these motors, and over time they're going to start to expand expand that wireless network to other devices in their treatment plant. So it allows them to eliminate the external labor cost for trenching, conduit, cable, and provide an easy solution that can be installed quickly and reliably for their application. And just an example of where we've been used in the past, you know, you can see, again, from a process standpoint, you can see those big names of Shell and Exxon and Sunoco, irrigation districts, the Marine Corps. We have a lot of experience with a lot of different players, whether it's oil and gas, water, wastewater, food and beverage, your standard factory automation and networking. So we've been around for a little while. We've seen a lot of things. I've seen a lot of things, and we're here to help, and here to help you advise you on what may be the best solution for a wireless application if you have it. If you have one, or if you're considering them, we can have a conversation with you and walk through that step by step with you and make sure you're going down the right track. So I'm gonna pass it back to Gene. I appreciate your time, and I think if we have any questions, we have a couple minutes for questions.
Thank you, Justin. That was very informative. I really like the applications to kind of give everybody an idea of exactly how they're used in those different situations, because, you know, wireless is definitely changed over the last couple of years. And, you know, it used to be a one size fits all, and everybody was trying to force fit a 900 megahertz for everything. And like you said, sometimes the update rate or refresh rate or the amount of data we have going across is not good for those situations. So it's really nice to have one place to go to get a little bit of everything or what we need for our particular application and not have to force fit everything.
Exactly.
Good. Nikki, do we have any questions that we need to address?
Yes, we do have a few that have come in, and just a reminder to the group, if you do have a question, the question area is over to the right-hand side, and you just open that up and type your question in there. So first question from the group: how do we know if the product will work in our environment?
So
Yeah,
I can start that and kick it over to Justin. So
sure.
we work with Phoenix Contact, and we can come out and do an application review and also look at the site to see what's best there. I think you've done one of those here recently, Justin.
I may not be me specifically, but I've worked with our local sales team that has done one recently, and I think it was Oklahoma, I want to say, that just did one locally. Yep.
So you can look at the different, either from a map situation or just a walkthrough and see how it works.
Exactly. So from that process, what we can do a couple different things to walk you through your application. Like you said, Gene, we can have a conversation. We can get on the phone. We can talk through it. From there, especially if it's a longer range application where you're going to go across an area where you're not familiar with. One thing that we offer from a Phoenix Contact standpoint is the ability to do theoretical path studies. And we still see my screen, Gene? We're good?
Yes, sir.
Make sure I switched. Okay, so what this does is you as the end user provide us with coordinates of where you want to connect things. And we run it through a software package and we simulate that link. So I happen to be working on one right now where you can see here they're trying to shoot through a big hill. So what I do through this is I'll work with you as an end user. You know, there's more sites involved in this one, but we'll work with you to kind of figure out, hey, is this the right solution for this radio technology? Or B, does it need to be a hybrid situation where, hey, this site can't get through that hill, so maybe that one will be a cell setup, but the rest of the network can be a private network. And then from this, we provide you with a full report of bill of materials and everything in the network. And then from there, you can work with Vector, you can work with Phoenix about coming out on site. And I've always been a big advocate of seeing is believing. So whether that's a Vector person coming out and helping you do a site survey, or we working to get a sample to you so you can install it with your force to make sure it works and you understand how it works together, I'm a big advocate of that, and Phoenix is a big advocate of that as well.
Good, thank you. Nikki, do we have a new one?
Okay. We do. We have a few more. Next question. How do we know which technology is best for our application needs?
Yeah, so that comes down to, again, there's three questions we asked back in the, or I showed back in the beginning. How far do we need to go? How much data do I need to send? And what kind of possible interference could there be, whether that's physical or RF interference, because all those will change things. And one I didn't have in there is, what are you trying to physically connect? Nowadays, you typically see a lot of different technologies with every type of connection technology, whether that's serial, Ethernet, or I/O on it. But it's important to pay attention to that, because you may find a radio platform you really like, and then find out, oh, I needed I/O and it only has a serial port, or it has I/O and I need an Ethernet port. So once you ask those three questions, that'll kind of frame you into what you need, because you'll know, hey, I need short distance, high bandwidth. Well, that really pushes you towards that Wi-Fi technology. Or I need low bandwidth, long distance, and that pushes you towards more of a 900 megahertz proprietary solution. So going down those three questions, and then again, if you're still having questions about what technology fits best, that's when you can reach out to the Vector or the Phoenix group, and we can talk through that application with you.
So Justin, when we look at longer range applications, do we have license and non-license options?
There are definitely licensed options out there. From a Phoenix Contact standpoint, that's not a place where we play currently. So my experience is that there's definitely a place for licensed applications. There's definitely a need for it. It can go really far distances and not a lot of input from a design standpoint. We can replace licensed applications with unlicensed. Again, that's where you kind of go where with the path study and site survey. Licensed applications just require you to go through the FCC and apply for a license for your hardware. So if you're familiar with that, it's not a hard process. There's a little bit of a fee associated with that, but it's typically a 10-year license, and the cost varies depending on how many sites and how you're installing it. I will say the one thing with licensed technologies is they are low bandwidth, kilobits per second, because of the way the abundance of that are out there now. The FCC has over the years reduced the channel bandwidth of licensed radios so that you can only shoot a very small bandwidth at a time. So I don't remember exactly what the highest data I've seen recently, but it's kilobits per second. But again, you're going 20, 30, 40 miles a shot with those.
Yeah. Thank you, sir. Nikki, what's next?
Next question actually is for Eugene. The customer wants to know, where can they purchase these products?
So yeah, I bet many of you on the phone maybe not have realized that Phoenix did wireless. You know, a lot of times we see Phoenix from inside of a control panel and seeing the wiring pieces to it, power supplies and that kind of stuff. So Phoenix has definitely expanded. It's gotten to a healthier group and offering. And so that's where Vector steps in. When we get into things that are a little bit more sophisticated, that needs some more engineering standpoints, Vector comes in and helps you with that. So we can provide you all the way from the terminal blocks to this, or if you want just the wiring, muxes, multiplexers, they do a lot of HART multiplexers as well. That can all be purchased through Vector, and we can put that in as a solution. If you have you know, flow meters or boxes and you want all that put together in a box, we can do that as well. So this is adding additional value to the customer.
Okay, great. Next question. How secure is this wireless communication?
Very good question. Justin?
Yeah, so, yep, so it's a lot of, you gotta look at each technology. So if you look at let's take the Wi-Fi, for example, because that's, everybody knows that technology. So Wi-Fi is only as secure as you make it. So our radios, like every other radio you have out there, will have the ability to set up security and encryption, password protect your access to the network and encrypt your data. So we have the highest level of security as available on our radios. And we also have the ability through our radios to create control lists. So if you're creating a network with an access point and the security, password, encryption is not enough for you, we have the ability to set up control lists saying only these devices are allowed to connect to my network, and you can set up a MAC address list. On top of that, there are the ability to send SNMP traps, which is a data protocol out of the radio that if something was trying to connect that isn't supposed to connect, send me an alarm. So you have that ability to be as granular as you can be, but with our Phoenix Contact WLAN and even with your WLAN at home, the most important thing is that you have a strong password that isn't easily discernible or guessed. So if you're using Phoenix 123, change the O to a 0, change the I to an exclamation point. Shouldn't use Phoenix 123 in general, but change those letters to make them some kind of characters. So when someone is trying to hack your network, or if they try to, they're not going to easily find a clear text word that they're when they go through that process. When it comes to 900 megahertz proprietary networks, the beautiful thing about proprietary network is it's proprietary. So Phoenix Contact is going to be the only person who knows the authentication practices, the algorithms in which we're hopping on the network or on the frequencies, and it's a pseudo-random pattern that never repeats itself. So not only would you have to have a Phoenix Contact radio to jump on the network, you'd have to know the network IDs, the passwords, and everything that's on there, and there's alarming in the network that would give you an error flag if something added to the network that wasn't supposed to be there. So being proprietary, there's an extra layer that's inherently secure about a 900 megahertz proprietary network.
That's great.
Okay, next question. What is the price comparison from a standard wired system to a wireless system?
Yep, that's probably the first question I always get when we talk about wireless systems, other than will it work? Price-wise, it really depends on the platform and what your wired network would involve from a standpoint of the trenching and the conduit and the cables and how many obstructions. But I'd say a lot of times there'll be some initial cost savings from the strictly just the hardware standpoint when you're looking at excuse me, I'm buying this amount of conduit, this amount of cable, and here are my labor rates, versus here's a radio, here's the antenna, here's the cable, here's my labor rates. You'll find some benefit from a cost perspective there. What people don't consider is, again, that damage to that cable. You know, I've had a lot of instances where they analyzed the upfront cost, said, hey, I wish I could save more here on the wireless, I'm just going to trench it. And then a couple months later, they come back to me and go, hey, I want to buy that system now because, you know, I backhoe dug up that piece of conduit that I laid 500 feet across my facility, and now it's going to cost me, you know, another 10 grand to relay that wire. Where if they just used a wireless system, you know, that wouldn't have happened. So it's not just it's not just looking at the initial hardware cost of a wireless system compared to a wired system. There will be some savings depending on the technology and depending on the overall scope of work, but it's also, again, that consideration of what happens if that wire breaks, how much will it cost me to physically replace it, and with my process, if that wire breaks, how much am I losing, you know, minute by minute, hour by hour, day by day in my process. So make sure you're looking at all three of those. Again, in my experience, a wireless solution is typically less expensive up front, but there's also that value in the back end too.
Well, that's part of looking at the entire application. You can't just look at, I need a wireless. Why are you putting that in? What's going to be brought back? You know, there's still a lot of companies that don't see they don't want wireless for control, but they'll want wireless for monitoring. And so it's what's important to you. We've put them on gas detection applications. We've put them on locations that are way off from the thing. So maybe a tank farm, it may be a loading rack that's away from the congested process unit. And, you know, that's several hundred feet to get out there, so we can do wireless back and come as a package. And it may not be the point-to-point that you're talking about. We may bring in, like you showed at the well pad, a lot of information into a central point and then trunk line that all the way back. So I think it has to do a lot with your application and what you're trying to accomplish, and stepping back and weighing out all the positives and negatives.
Yeah, and just weighing what the benefits are. I mean, I've been doing wireless for 10 years, and I still tell people, you know, if there's a plug there and you can plug it in, plug it in. I mean, there's no point in trying to shoehorn a wireless solution into something that has a wired connection. I'll be happy to sell you one, but I mean, if it's there, plug it in.
Yes, sir. I agree.
Okay, it looks like we have one more question here. How do we know which antenna to get?
Yep, that's another good question. So, so we have a couple tools. In that wireless catalog that is in the handouts, there is a section in the back that helps you select your accessories to a system. So it's a table. It kind of goes, hey, if you're using this technology and you're going this far, here are the different antennas that take you roughly the different distances. We also have a configurator on our website, Phoenix Contact's website, that has an antenna guide that, again, helps you put together those antenna assemblies. And again, if you're really questioning how, you know, I'm going a long distance, I'm going through these trees, I just don't know, that's, again, where this path study service we provide through Vector for Phoenix is very valuable. We'll be able to provide you a full bill of materials based on the coordinates you give us and the technology that you're looking for. And again, if you don't know the technology you're looking for, you just tell us, hey, I'm looking to do A, B, C, D, E, F, G. I have these sites. Here are my limitations. Here's what we're looking to do, and we can, again, have that conversation, work through the path study, and then, again, we have the ability to come out on site, either that's through Vector or through a Phoenix local Phoenix contact person, and we have different antennas available to us for demoing that we can, you know, prove out which one's the best for your application.
No, that's the value that we can provide. Is you don't have to know it all. You don't have to guess and see what happens. We can help you get to that point and even test it out from there.
Exactly. Seeing is believing.
That's right. Anything else, Nikki?
Okay, great. No, I would like to thank everyone for joining us, and we trust that it was a worthwhile experience for you and that you learned from our experts some valuable takeaways. Any closing comments, Gene?
No, I just want to thank everybody here. If you haven't visited our website, we launched a brand new website at vectorcag.com. Please look at it. Our company is continuing to grow, continue to add new applications, new coverage areas, new product lines. We are here to help. We are here for the solution. We're not here just to fulfill an order, and we're truly interested in helping you make your application successful. So I want to thank you, Justin, for your input and spending some time with us this afternoon.
Yeah, thanks for having me. I appreciate it.
Hey, everyone have a great rest of the day.